Hello again. All right, so what we're going to talk about next is, once you have a name, obviously you can use it for a method or a class or a variable. And I want to spend some quality time now talking about variables. So the first question that I want you to answer as we talk about variables is this: what are the attributes of a variable? And if you're not sure what I mean by attributes, then you can think about it this way. What are the things that you have to think about or worry about when you want to declare a variable? All right, and so to answer this question, so that you're not just sitting there listening to me, I want you to try and come up with a list of things that you have to think about when you're dealing with a variable. All right, hit pause and think about this for a little bit. I'll give you a hint. There's actually 6 things you should be thinking about. So see if you can come up with 6 things. All right, and hit pause. All right, I assume you're back. Hopefully you've thought of a couple of things, and so I'll spill the beans. So one of the things is how we deal with variable names, the name of variable, and we just spent some time talking about that. So I'm not going to talk about that anymore. Another thing you need to be concerned about is what address is linked to the variable. Another thing you need to be concerned about is what the value of a variable is. Obviously, you need to be concerned about what type the variable is. You need to be concerned about the lifetime of the variable. And you need to be concerned about the scope of the variable. So we're going to talk about each of those in turn. And I think that the reality is you probably know at some level, whether it's conscious or not, these are things that you do worry about when you work in Java, for example. But if you're learning a new programming language, you need to be totally conscious of these different attributes, because if you don't know the answer to the attributes, these 6 attributes for any variable you use in a programming language, then you don't really understand how to use the variable. So let's talk about value. Let's talk about address first. Move that up here. Okay. So address of a variable. Well, the address is the memory cell that's linked to the variable. So what makes this kind of interesting to me is this question. Let's see if you can answer this. Can a variable name have 2 different memory cells? So that's my big question here. So again, hit pause, think about this for a second, and let's see if you can come up with an answer. So if your answer is yes, you need to tell me why, and if your answer is no, you need to tell me why. And I think the best way to do it is to answer the question is to give some sample code. All right. So hit pause, write out a little piece of code to answer why, yes or no, and See what you come up with. So hit pause. Okay, so the answer is, it depends on the language, but in some languages the answer is definitely yes. In Java, which you use all the time, the answer is certainly yes. So I can give you an example of this. If I have a method, subroutine 0, I can say int I equals 0, and then I can have another subroutine, subroutine 1, and int I equals 3. So certainly I can have that. I could also do this in a for loop, right? I can say for int I equals 0, blah, 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 and then for int I equals 0, blah, 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 in another for loop. I could also put I as an argument, or a parameter, sorry, in a method, and use it again as a parameter in another method. So there's a lot of different ways that the same variable name can have two different memory cells. All right, so that kind of takes care of address. Let's talk about alias. I feel like singing the Secret Agent song. Yeah, I don't know if you know that. Secret Agent, man, they've given you a number and taken away your name. Well, what the idea of alias is not that the same variable name shares multiple addresses, but here what we have is multiple variables variable names sharing the same memory cell or address. So can you give an example where we have multiple variable names sharing the same memory cell? So that's another thing. Hit pause and see if you can give me an example. And hit pause. And we're back. So if you didn't hit pause and you're just sitting back and watching me do this, I would think that's incredibly boring. So try to take advantage of the pause to work some of the stuff out on your own, because it'll make more sense and it'll certainly help you on the exam when we get to that at the end of the semester. All right, so let's do an example in Java where we have multiple variables sharing the same address. So if I say string s equals hello, and then I say string p equals s, and then I say p equals p plus world, and I say s equals s plus world. What's going to happen if I look at p and s at the end of this? And the answer to what's going to happen has to do with the fact that, at least for a little while, p and s actually refer to the same memory cell. That actually happens right here when I declare that the reference p, the string reference p, is equal to the string reference s. If you recall from discussions in CS1, this s here is actually not the string hello. It's a reference to the string hello. So if I draw this, okay, I've got s, and s is a chunk of memory that refers to the memory cell that contains the string hello. And p, likewise, refers to when we say string p equals s, we're saying that the reference p is going to refer to the same thing that s is referring to. When I say p equals p plus world, p no longer refers to the same location as s, because any manipulation of strings are immutable, so anytime you try to change a string, you actually create a new string. So we end up with p referring to hello world, and s, likewise, is going to refer to its own hello world. So we say that p and s, not only are we calling them reference variables, but as in a more generic, using more generic terminology, they're aliases. They're aliases for the same chunk of memory that, at least initially, they're aliases for the same chunk of memory that contains the string hello. Okay, great. Now, is it a good practice to have aliases? And the answer to that is, well, I think if you're using a programming language that has aliases or references, and you're not careful about how you manage those references, you can get into trouble. You can't get around it. You definitely need to have aliases in a programming language that uses dynamic memory. All right, so let me write this. So the answer is, it depends. So on the one hand, it's bad if you have multiple aliases. It's going to hurt readability. Multiple aliases for the same cell. It's going to potentially hurt readability because a change to the memory cell through alias A is also going to change it for alias B. But if somehow in your code you're thinking alias A and alias B are referring to separate memory cells at some points in time and referring to the same memory cell at other points in time, things can get kind of confusing. But it's also good in the fact that it's a mechanism for supporting dynamic memory. And dynamic memory is crucial for many different types of for supporting many different types of data structures. Right? If you want to build a binary tree, like we talked about in one of the introductory lectures, if you want to build a binary tree, a really nice way of building a binary tree is to create a node and links between nodes. And you don't know necessarily how many nodes you're going to need, so you can't pre-allocate all that stuff. You really need to use dynamic memory and something like a new statement to create your node. Well, when you create a new statement that carves out a memory cell, and you need something to remember where that memory cell is, and that's what an alias is going to do, right? If I say in Java, if I say node n equals new node, all right, the act of saying new node is going to carve out a memory cell for me. This is my node. And now n is going to refer to that. And then I can populate the node, and I can reuse n again assign n to reassign n to another node as I build my binary tree. Okay. Um, another actually good practice for or a good reason why you might want to have aliases around is because that can be the mechanism that supports call by reference parameters in a method. So I'll give you an example of that. Maybe we have a method that we're going to say, we'll do this in Java. So public void populate. Let me get that spelled correctly. Okay, public void populate. And what populate is going to do is take a node n, and maybe what it's going to do is take an int value, and it's going to store that value in node n. All right. So since node is a complex data structure, it's not a simple data structure. In Java, all complex data structures are accessed by references or aliases. So this node n here is an alias for some chunk of memory. All right, and there's some code here that does population of the node. I'm not going to write that code. But in the main program, we'd see something like this. Let's say, I'll say node x equals new node. Okay, and now x is referring to this node that is going to have, assuming it's, for a binary tree, it's going to have some unknown value for the integer that's stored there, probably defaults to 0, and it's going to have a null for the left and right point references to child nodes. All right, and then I could say populate x, and let's say we want to put 42 in there. All right, so the goal of the code here is to stuff 42 in node. But in the process of doing this, while I'm executing populate, node n comes into existence, and n acts as an alias which also refers to the same node because we passed x in as an argument. So now I have two aliases for the same exact chunk of memory here. And that's necessary because that's the mechanism. Aliases are the mechanism by which we support call by reference arguments. All right. So that takes care of talking about aliases. So let's talk a little bit about something else. When we declare, so I just want to pull back for a second and remind you, like, what are we talking about? What's the big picture thing that we're talking about in this lecture segment? We're talking about variables, and there's 6 characteristics or attributes of variables that you need to understand in order to understand how to use a variable in a language. So one is name, which we've already talked about. Another is address, which we've talked about. Another is value. Another is type, lifetime, and scope. So we spent a lot of time talking about address and also aliases, and they're intertwined because an alias is a way of having multiple names for the same address or memory cell. So let's see. So the next thing I'm going to do is talk about type. And the question that I want you to answer for me is, all right, if you know the type of a variable, what does that actually determine for you? What does that tell you about the variable? So hit pause, think about it. So hit pause. And we're back. So here are the things that are determined by type. One thing is the range of values that the variable can support. It also tells you about the memory consumed by the variable. It also gives you information about the valid operations on the variable. So here's an example. Let's take an int, all right, let's say it's in Java, because you guys are familiar with Java. So I'm just going to go through the list here. So what are the range of values for an int in Java? And if you're not sure about this, think about it for a moment, and then I'll spill the beans. So you can pause, think about it, and then I'm going to spill the beans. And I'm now spilling the beans. So here is what I do to figure this out. First thing I do is I know the memory consumed by an int is 4 bytes, which is 32 bits. So the first thing I do is say, hey, well, if that's true, then I would say that the range of values would be something like 2 to the 32. But there's a catch here, because ints can be positive or negative, and so there's 1 bit for sign. So that means it's really 2 to the 31. All right? So 2 to the 31 in the positive direction, 2 to the 31 in the negative direction. That's awesome. There's only one problem, and that is we have to account for 0 as well. There's no value of 2 to the anything that will give us 0. There's no set of, right, if 2 to the 0 gives us 1. So the range is actually minus 2 to the 31. So that gives me a whole range of values in the negative direction. And then it's 2 to the 32, or 2 to the 31 minus 1 in the positive direction. And this minus 1 is to account for 0. So I go from minus 2 to the 31, right, to minus 2 to the 0. That's going to give me my range of negative values. And then I'm going to go from 2 to the 0 to 2 to the 31 minus 1. That's going to give me my range of positive values. And then I'm going to have 0 in the middle. So that gives me the total range of values for an integer type. The other thing I need to do is list the valid operations on an integer in Java. And those are plus, minus, multiply, divide, and modulus. Cool. What do I want to say about value? So that takes care of type. Let me talk about value for a second. So if I have a particular variable, all right, and I've declared it, and it has a particular type, it has a memory cell that it occupies in memory. One of the other things that I need to know is what does the memory cell contents look like for a particular value? So that can get very interesting. You think, oh, why would that be? That can get very interesting, and we're going to spend some time a little bit later in the semester talking, actually fairly soon, talking about the representation of value in a memory cell. So I'll give you examples of two things that we could spend a lot of time talking. We're actually going to spend time talking about, but not right now. So for something like an int, right, an integer, we have to worry about big and little endian, E-N-D-I-N, representation, because different types of hardware represent integers differently. So that's kind of weird. And for any kind of floating point, for example, a double or a float, something with decimal representation, that gets really interesting as well. I mentioned in our in CS1 that the computer's representation of rational numbers isn't very good, and in fact, even representing something as simple as 0.1 is not something the computer can do very well, which is a big problem if you're dealing with financial type applications. So I'm going to talk about the representation of floating point and talk about why something as simple as a 0.1 can't be represented very well. But it's really important for you to understand, if you're working with variables in a new language, what the memory cell contents look like for a particular value. All right, so that takes care of value. I think that's a good place to stop. We'll deal with binding issues next. The binding issues are going to relate to the issues of lifetime and scope. And we may revisit type again as well. Great.